this is an amazing turnout. So I am Sean Metcalf, and this
You're so handsome!
Thank you! I work hard at it. So this talk is from Workstation to Domain Admin. A little bit about myself. I'm the founder of Trimark, a professional services company that helps organizations better secure their Microsoft platform, including the Microsoft Cloud. I am a Microsoft certified MCM Master of
Wait
Directory
a second,
Services.
hold up. You are not Sean Metcalf. I'm Sean Metcalf. I swear you do a talk about like securing administration and you get someone impersonating you. It's crazy. So I'm Sean Metcalf, founder of Trimark. Thank you, Jason. Microsoft Certified Master in Active Directory. I've spoken at a number of conferences, security consultant researcher, and I have posted a lot of information on adsecurity.org. Hopefully you know it. If you've been there, have used it, raise your hand, please. Awesome, thank you. If you're not raising your hand, talk to the people that are raising their hand and find out why. Also, in a tradition that started in Vegas at Black Hat and DerbyCon, my daughter asked me again to bring Bunny. And then my other children were like, hey, can you bring our animals too? So hopefully I don't have more kids because this is really crowded up here. But there's a couple of things that have changed recently, so I probably need to update the slide, and I'm an MVP again. So, what are we going to talk about? The current state, the current issues, the evolution of administration, and then we're going to look at how MFA, password vaults are hacked. Basically, how do you bypass them? How do you go around these methods that people have used to administer and secure the administration of Active Directory? And we're going to close out with building the best defenses, or attackers find a way to DA. So the current state of security, it is much better than it used to be. We have more security software, we have event logging, we have SIMs that are getting events, getting information. We're looking at those. We may be overloaded by events, but we still have it. There's vulnerability scanning that is done to highlight some of the issues. We have security software agents that are out there. So we have better insight and visibility into what's going on. But many have not changed how administration is managed, administered, etc. We still have the same problems. And in the beginning, we have a workstation. We have a happy user doing what they normally do. They can do everything they needed to without too much external support. That changed, and we added more people because we have desktop support. We need other people to help out with problems, install software, fix things, right? And then we decided it was too difficult to have a bunch of people running around trying to fix problems every time a user clicked on the wrong thing or deleted something, so we added agents for patching and management. And this expanded, so on and so forth, and now we have whole operation centers to manage and monitor this whole situation. But what have we done, really? We've gotten into a situation where we have one workstation on the network. There's 30 accounts in the local administration group through group nesting and other groups. We have 50, whoa, that was good. Yeah, exactly. That's my point exactly. If someone has access to my computer, they can do a lot of crazy stuff.
Was that one of the animals?
Yeah, probably. Here, you're going to have to go on a timeout over here. Timeout. Bad rabbit. Okay. So 30 accounts, 50 accounts with local admin rights via the software management system, 20 accounts with control of the computer via security agents, and that gives us about 100 accounts with effective admin rights on this workstation. This is not uncommon. These numbers may be low in some environments, very low, might be slightly high in others. But ultimately, who has control of this workstation? Who's managing this workstation? Who has access to it? So we've evolved our administration around from VNC to remote desktop to using the MFC on a console on the system itself, using run as and other methods to bring up these applications and be able to administer, to RDP into another system, to connect to there, do our administration there. I only have 45 minutes, 50 minutes to do this talk, so I'm going to get to that. I get through a lot of content first. Thanks, Dave. So as we go through the administration, we have a lot of these things that are there that were on the workstation. And the problem is there were admins everywhere. We had users in domain admins. We had local administrator accounts with the same username and password. Many environments still do. So we end up in a situation where admins are everywhere, it proliferates, like a bunch of ostriches. They just show up and you don't know why they're there. So this resulted in a situation where we have a target-rich environment, where we have pen testers and red teamers that are just basically plucking out the salmon as they jump into our mouths. It is way too easy. If you're a red teamer here and you think that things are hard to actually exploit an environment or get DA, raise your hand or clap. Wow, the sound of silence is deafening. So we still have problems. Why? Because a lot of the times we have our old school admin methods which are still in use. Credentials and LSAS, credentials and LSAS, credentials and LSAS on the remote server. And as our illustrious keynote speaker, Mr. Benjamin Delpy, talked about, using Mimikatz, you can dump these credentials and get them fairly easily. You need admin rights, but come on, it's not that difficult to get admin rights on any given Windows box at any given time. So that's not a high bar. Many users still have admin rights. So the newer secure admin methods are supposed to solve all this, right? We have a situation where we are connecting into an RDP server, or we're not using our run as anymore, hopefully. We aren't using our MMC locally on this workstation. We're going to connect into that other server using our RDP client. And so we're going to type in our credentials and connect to it. And maybe even we're going to use MFA, something like Duo, so that way we have some strong authentication that we know that when we connect to it, it is the admin that's actually connecting to it. But the challenge here is that we have concerns about those credentials. So what do? We then use something like a password vault. So Psychotic Secret Server or CyberArk are the two bigger ones that we see a lot of times, usually more CyberArk, but still. But there's problems here. We have not solved the real problem. Even if we're using MFA, even if we are using a password vault, we haven't really solved that problem. Because we have our user account on our system, but then we're typing in our credentials to connect to an RDP server. We're still typing in credentials on a regular workstation that potentially 100 other people have access to. They can get admin rights on. So let's go through a couple of scenarios where we type in, we connect to our RDP server, and then all of a sudden there's this really weird temp file that gets dropped to the C drive. I don't know what that is. Maybe I never even noticed it. But what had happened is that there's a WMI implanted task on the system that an admin dropped, or someone who is an outsourced admin. And what it's looking for is mstsc.exe. And as soon as it sees this, it's going to run this innocuous script called sccm health check.ps1. But this is not the altruistic script that it sounds like. It's actually going to be running this powersploit function called gets keystrokes. And so what it's doing is it's key logging from PowerShell everything you type in once you pull up the RDP window. And so that means if we open up this temp file, we're going to see something like this, which is going to outline and show us every single character that we typed in order on that system, or on that system to connect to it. And we can go through and look through all this, but I prefer to use PowerShell and just go ahead and pull that together so I can see exactly what was typed in, which makes it very easy. There's another problem is that we have had a situation where we have a lot of legacy and old configuration of administration that's out there for a while. The default domain controllers group policy is one of the biggest sources of gold for an attacker I have ever seen on a network. Now that organizations have started reducing and removing members from domain admins, which is good, they don't check user rights assignments in Active Directory. And this is very difficult to read. I don't think anyone in the front seat could read this, but this is to point out that there's a lot of settings in here that you definitely want to look at, because there are a ton of security issues in this test environment. And these are indicative of what we find when we do security assessments for customers. And one of these is allow logon locally in this GPO. So if you see something like that, where domain users is a member of that group, of that right, this is domain controllers. That means any user in the domain can actually log on to that domain controller. So what does this mean? Maybe they could walk up to the console of the domain controller, but if your domain controllers are in a data center, then they probably can't do that, so we're good, right? Well, what if we can get remote local access, like something like a VM console or ILO? And let's say hypothetically that maybe there was a vulnerability in ILO, and that hypothetically people don't actually upgrade their firmware or patch ILO after they install their servers, because they never do. I worked in operations for a long time. I never wanted to install firmware updates unless I had to. This patch has been out for a year. So the team that discovered this was from Airbus, and they realized that all you had to do was send a bunch of A's to overflow, and then you could get into the ILO system, and you can get RCE. So really, this is brought to you by the letter A. So I thought that was a really clever joke, right? And I posted this slide on Twitter, and I was like, yeah, this is great. You know, a bunch of people had retweeted it, like, that's pretty funny, letter A. This one guy is like, hey, Sean, you forgot the obvious. Would have been better with the fonts. So Rob Campbell, thank you very much. Hey. But then Sam was pointed out, actually there's a new one on ILO that came out this year that I completely missed. And so there's another issue that just came out in June. So it's important to understand that if you have ILO, it needs to be on an out-of-band network. It's not supposed to be on the same network as everything else, but you'd be surprised how often that actually happens. And Snorky, who works on the team, said they're going to disclose more information on that as well. So like I said, if you can log on locally on a DC, then you can log on. If you also have the ability to log on through terminal services or RDP, then yeah, you can RDP and log on to the domain controller over the network. And this server tier 3 configuration here is actually fairly common. It's more common than you would think it would be. And who's a member of server tier 3? We got this guy, Eddie, who's in the users OU. Well, guess what I can do now? I compromise Eddie, and then I can log on to the domain controller and do fun things there. So fun fact, on HP servers, there's actually a CHP folder, and sometimes, all the time, there's a service that runs an executable from that location, which I believe is writable by the user. So manage auditing security logs, it's another big one. You'll always pretty much see Exchange in this, but Microsoft points out that anyone with this right can clear the security log. So if we have a group like lab admins that has this right on domain controllers, they can clear the domain controller security logs. And hopefully you're logging and alerting on 1102s, right, like Jessica Payne always says, because that will tell you if the event log's been cleared. And so some environments have gotten a little trickier, so red team and pen test teams have to actually identify what rights or how are those admin accounts configured. If you find that there's a bunch of admin accounts and domain admins or administrators, and you think, I'm going to get one of those, well, you might want to check out logon hours and logon workstations as well. Because if they have these configured, you're not going to be able to use these counts just about anywhere on the network, per se. So there are some restrictions you want to start looking at, especially as some of the more the deceptive technologies are used more, as well as administrators are starting to lock down and better protect those accounts. These are not necessarily the best way to do it, but it is the first step of something you can do to help mitigate the issue of admin accounts getting exposed. What about MFA? So if we MFA the RDP, we get RDP that's MFA, we get our RFA and our MFA and our RDPs and all these acronyms, we put them together and we get security, right? Just one big security suit that's perfect. So we take our RDP, we put MFA on it, and we're good. Well, I'm not picking on Duo, although they are part of Cisco now, so maybe it's fair game, I know. But if we have Duo, Duo's great because it pops up this message on your phone. And then you can say approve or deny, which is nice, right? And so we have some information about it. We have the IP address, what the user account is. I look at it and go, yeah, I just attempted to do this authentication to this RDP server, so I'm fairly confident that's me. So I click, yeah, I'll approve. What if I got two of these together, like boom, boom? What does that mean? Is this a race condition? Is this someone watching what I'm doing and hitting it at the same time, or has it hiccuped? Now, I'm a security guy, so naturally I would think this looks weird. But we've all done stuff before we got coffee that we probably thought that wasn't a great idea, right? So, boom, approve, wait a second, what did I just do? I think it just hiccuped, maybe that wasn't a big deal. I hope it wasn't a big deal, I'm sure it's okay. And what if the attacker sent the first one and the second one was mine, like the legit one? So that makes it a little bit more complicated. And what if we have a situation where we're actually authenticating through ADFS? There could be a hiccup there. We are authenticating through that to a couple of different systems. What would happen with that? What if we don't even unlock our phone? Well, that's going to look a little bit differently. we're going to just see this basic information. Now we might get a couple, whoa. There's some weird wireless stuff going on with this, so I'm going to stop doing that. There we go. So what if we got a second one? What if we got a third one? Like approve, approve, approve. I don't know. I don't have any details there. And unless I actually get into the phone and look at the details behind it, because Duo gives an IP address and some additional information around it, I don't know what's actually happening. So if we're attempting to subvert MFA and kind of creep through it without anyone noticing, there's a few things that we could potentially do. Let's say that Acme has enabled our users to update several attributes through a self-service portal. A lot of large organizations have this. So they do the usual ones: phone number, work address, mobile number, or work-specific attributes, or whatever. Some people see where I'm going with this. And so they have 555-1212 as their mobile number, which works fine, which isn't used by anything in this organization that anyone really cares about for the most part. So let's say the attacker changes it to 867-5. And what's interesting about Duo is when you get into the system, you have a couple of options, and one says passcode. If you click on this, it says send me a text. And it'll use that mobile number in a lot of organizations that's associated with the user account for admin authentication. This is fairly standard based on what I've seen. And so if we have a situation where the attacker can change that mobile number that's used, when you click on this and say send me a text, I now get a text to my phone instead of the admin getting a push to theirs. And so the admin will never see this. The same thing with others, like Okta. It's a similar situation. Text is almost always the fallback, almost always the backup. So if you have something like this, you want to make sure push is the primary method so they get a push no matter what. Again, there may be ways around that. So disabling text is one of the best ways to do it. So this is a summary for people who are looking at the slides later. But then I was given this other information about how Duo actually works behind the scenes. And so Duo fails open by default. So bypass Duo authentication when offline. So this is the standard configuration. So if that server can't communicate with the Duo servers, then it's going to go, okay, go ahead and get in. So what if I were to go ahead and mess with DNS or change something so that way that communication could not happen? Now I've completely turned off MFA on that system, because if you look at the DNS record here, there's an API DNS record for that specific customer, .duosecurity.com. And so this is another one, only prompt for Duo authentication when logging in via RDP. So you leave this unchecked for local logon and RDP sections. But if we enable this, local logons don't require MFA. So that gets pretty interesting. So thanks to Nupi for doing a great blog post on that. Then we talk about the other issue behind this. Let's say we go after the MFA onboarding. Very often, MFA onboarding is something simple like an email address. Well, guess what? If I've already compromised the user account, what do I care that I have to click on a link to approve an MFA request? So I could actually enroll into MFA for that user, or I could just call up the help desk and be like, I lost my phone, or my phone got damaged. Can you set up this new phone number temporarily? I'm with Mr. Kawasaki, the VIP, and we got to get this stuff done today. Can you do this? Because he's going to be upset because the TPS reports aren't going to be done tomorrow, and we're using new cover sheets on them, and everyone keeps forgetting that part. So, yes, use MFA. It has value. There's a lot of things that you can do to improve MFA, to harden it, to understand what its weaknesses are. And this is more of a reference slide. But does it have value? Absolutely it has value. Please MFA all the things, especially in the cloud. You have cloud admin accounts, absolutely MFA them. But just don't count on them to be a silver bullet. They're not going to solve the problem. They are one part, one layer, one mitigation option that you have in your environment. So the other thing we see a lot is organizations deploying password vaults. CyberArk, Thycotic, Lieberman has one too, but I haven't really seen that. So more broadly, oftentimes you'll see a reconciliation account in DA. And if they have CyberArk, it's almost always called CyberArk blah, 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 right? So you know it's a CyberArk reconciliation account. So it probably has a really long, complex password. You're not going to really be able to do anything with that, but it has access. And that account is often used on the CyberArk servers and systems that are part of that component. This password vault maintains AD admin accounts a lot of the time. And there's often additional components such like a session manager. So how is this often deployed? Option one is the admin person is on their workstation, they log on, they connect to the password vault website via HTTPS. They copy the password down, so the password is in the clipboard right now. So they can paste it into the RDP window, and then they can get into the server. I've never seen any admin have their web browser open and their RDP window open, and they're like, what is the number? Okay, X5, 80%, blah, blah. Now they're going to copy it and paste it because that works. It's not an LSAS. It's not on the system somewhere else. But there's this really interesting PowerSploit function called Get Clipboard Contents, which we can do just like we did before. So all we have to do is monitor the web browser use and the title of the window, the web browser window, to see what they're going to. If it says something like CyberArk or PDA or something like that, maybe we initiate this and start getting clipboard contents from that environment. And then we can get something like this at the bottom where we can see actually what was copied into the clipboard. And of course, once we have that, it's pretty easily to correlate that with what the account is, especially if we do something else with that, such as like a keylogger or along those lines. Or even something else from PowerSploit called Get Time Screenshot. So we can start doing screenshots along with the other pieces that we're doing to pull together a better picture of what accounts are actually being used on this regular workstation that 100 people have admin access to. And so as you see, we type in our credentials here, and we automatically get those credentials showing up here. All right, so the admin says, I see the risk here, we're not going to do that anymore. What we're going to do instead is we're going to use the password vault as an RDP proxy. We are going to connect through HTTPS. I'm not going to know the passwords for my domain admin accounts. I'm going to auth to my password vault, and then the password vault is going to connect me automatically through that website to the RDP server where I'm going to do all the work. It's going to authenticate me to that system. So that way no one's going to know what the password is for the DA. Okay, that sounds pretty good, but who logs on to that workstation? That's the user. There's 100 admins that have access to that workstation. Who logs on to the password vault? Too often this is the user account that's used to log on to the password vault. Not a good idea. What if you use MFA? All right, well, we talked about some of the potential issues with MFA, so that can help, but we still have that concern and that issue. And then who administers that server? Most of the time, I find CyberArk servers in the servers OU that the server admins have full admin rights to, and the group policies that manage them. And there's like 50 people in that group, including user accounts. Are the network comms limited to the actual password vault? Who can connect to the system on the network? It's a web server. If we don't restrict this to just the admin use, someone might be playing around to see if they can get something else out of it. So there's another interesting thing that I was thinking about this. When I saw that admins actually open up their web browser and connect to their password vault, is there a way that we can compromise the password vault access through the browser? And then I started thinking through this a little bit further, like what's the best way to compromise the browser? Ooh, a malicious extension. What if we just drop malicious extensions throughout the environment and just start monitoring what people are going to? And how about if we just like create a secondary session to our password vault within that web page or within that web browser session and steal that token that's used to access it and start extracting credentials or maybe even pass through RDP from there? And this is a big problem. CyberArk admins, user, user, user. A raptor is going to take advantage of that. I'm sorry, I love that picture. I think it's great. So password vaults, I also find them on the internet. So CyberArk on the internet, CyberArk on the internet. The one on the left, actually no, this one here is an old version of CyberArk, which actually is vulnerable to a pretty major exploit of RCE. So be aware of where your password vaults are and how they're protected, because there's a number of potential weaknesses depending on the deployment. So I talked with some folks in CyberArk, and they said, well, this is counter to our best practices. And I said, that's great. Are they documented? Do you tell the customers this? Do you give them that information? Do you walk them through that? Because 80% of the time, this is what we find. CyberArk has domain admin credentials, and yet users have administrative rights to CyberArk, or can connect to it. So the vulnerability I was talking about, basically there's a REST API prior to 995 and 10x, which allows remote attackers to execute arbitrary code via serialized .NET objects in the authorization HTTP header. So RCE, but also they can mess with it and say, I've authenticated as the admin, the password vault admin. Now I get in, now I want all the password vault data. So if you have CyberArk, make sure you're patched against it. This is some information about it. I've got the link at the bottom for more reference and material and information. So a question I get a lot, I'm hanging out at the Trimark booth afterwards if you have questions. This is one I get a lot. What about the admin folders? What about the red folders? This solves the problem, right? We talked to Microsoft, they said this is what you should do. And you know what? They're right. The red forest can solve some problems, can solve some issues. The issue of 80 admins with their credentials spread out throughout the entire environment and not being well protected, DAs, etc., this can help with it because what we're doing is moving those to this admin forest, this ESE. And there's some key components to this of how it actually works. We've got high security configuration, we've got network isolation, we have to use PKI in this new environment, we have smart cards, we're rotating password hashes, they're not in an admin group full time. We can take a lot of these good best practices and port those over to what we're doing in our production AD environment and isolate our admins into an OU and on different systems. So we can take a lot of these great concepts and harden what we already have. Because there's some pros and cons to this. Well, like I said, it effectively isolates our domain admins. When deployed properly, it can be effective in limiting attacker AD privileged access. Notice that there's a couple of conditional words there like can and when properly. But there's some cons with it also. This is not something you can just pick up on a weekend and get deployed. The typical method of deploying the red forest or ESE or admin forest is to have Microsoft come in and you're basically going to take a big bag with dollar signs on it and hand it to them. Depending on the size of your organization, it might be a dump truck full of those. I don't know if you happen to have dump trucks full of those bags, let me know because I'll help you move them. But the thing is that this doesn't necessarily solve all the problems. It's very expensive to deploy, not just to implement, but the follow-on management maintenance, which means only some of the largest organizations with some of the biggest risks and concerns are really going to deploy a red forest or an admin forest because of the management overhead and cost. You're not going to do this with a 5-person shop. You're not going to do this with a 10-person shop. You're going to have to need a dedicated AD team that's going to be managing this. And their life is going to be a lot more difficult because operationally, this is expensive. It can increase the amount of time to actually fix things, to get things going, because they have a key ring of smart cards that are their admin cards that give them access to things. It doesn't fix these production AD issues. This is the biggest issue. This is the biggest problem that I have with the red team or the admin forest, is that you go and deploy it. You set up this admin forest. You move all of your AD admin accounts into it. But we've done nothing in our production AD to actually tighten it up and solve it. The other part is we have workstation admins. We have server admins. They have extensive rights to those resources, to those areas. That needs to be fixed. We need to figure out how to deal with that. And what about service accounts? Everyone knows in an organization or environment, or you work in an environment or organization, there is one service account that's in DA that no one wants to touch. Why? Because somebody says, Bob set that up 8 years ago, we cannot touch that. Okay, what does it do? I have no idea. Okay, well, why don't we do the screen test and disable it over the weekend? Oh no, we can't do that. That would be bad. Well, why? How is this application supportable if we don't know what the dependencies are, right? So when we're talking about admin forest discovery from an attacker perspective, it's pretty easy. We're going to look for a forest trust that looks like this and with some interesting naming to it, usually. And we also will find something like this, where there's an AD admins group or another group from another forest that's nested in the administrators group. That's a pretty key indicator that there's an admin forest in use. So when we look at this, we can look at the trust to figure out what that information is and how it's configured. We can check the trust, obviously outbound, so it's a one-way trust. And as we're going through this, we can do the same thing. I'm just showing the difference between the GUI and actually using something like PowerView to get information about it. enumerating administrators, and you're going to see something here that says foreign security principles. That means it's coming from another forest. And it's going to have that really weird information on the bottom, that weird DN, because it has the SID, which doesn't resolve because it's from somewhere else. And then we have that information that is from another forest. And so even if we have that admin forest, even if we have this red forest, service counts are always going to be the issue. If we have service counts and backup operators, for example, we have a service count backup AD, and we have an actual computer account that's a member of backup operators, which by default can log on to domain controllers. And this backup account is in this server's OU. Well, that's going to be a fairly easy and obvious way to escalate through that environment. So the first one's a computer account, the second one is obviously the service account. So we can exploit the prod AD with an AD admin force. We don't necessarily, as an attacker, care about an admin force. I can tell you this today, that the majority of the time that if you have a red force or an admin force, there are ways to compromise the production AD force without ever touching that admin force. I've worked with an internal red team to actually do something like this. Because these issues persist, they're still around. And just by setting up this new environment, moving AD admins there, we still have all the other permissions that have been there since the beginning. The other thing we see for cross-forest and multi-forest is, let's say we have forest A and we have forest B, because I'm super creative with naming. So forest B is our external forest, it's a DMZ forest, it's a dev forest, whatever, it doesn't matter. Forest A is our production forest. There is a trust where forest B resources trust forest A users. So forest A users can connect to forest B, connect to resources, do whatever they need to do. This is very common. And so we have our happy admin over here, who's a domain admin forest A, so obviously they're going to be a domain admin forest B. They're going to RDP over to forest B to do what they normally do. But if forest B is compromised, when you RDP into another server, you drop your credentials on that server. So just by doing that, we've compromised, forest B has been compromised, we compromised the forest A domain admin account, and ultimately our forest A. Just because we had a one-way trust between these two forests, which, by the way, in Microsoft documentation says this is the way to do it. We need to be careful of these sort of configurations. We need to ensure that if we have cross-forests or multiple forests and we're doing cross-forest administrations, we do not have the domain admin in one forest, our production forest, our trusted forest, also administer that same account, administer that other forest. We either want a separate forest account on the one side or a different forest account on the other side. So how can we defend against this? How can we protect our environments? Well, we need defensive pillars. We need administrative credential isolation and protection. We need to harden our environment, our administrators. We need to reduce and limit our service account rights. And we need to do effective monitoring, which unfortunately I don't have time to cover in this session. But I have some slides at the end. When I publish the slides, there's some bonus content. But we need to focus on protecting our admin credentials. That's the most important thing you can do. Protect your domain admin credentials, your AD admin credentials, anything that's in it, especially service accounts. Work to get those out. Use distinct naming so that you can programmatically monitor who are a member of these groups, and if there's someone that's not named as per the spec, get them removed. Automatically, there's no need for them to be in there. And make sure our AD admins only log into the systems they should. The question I get all the time is, why admin workstations? That's hard, that's painful, I don't want to do that. I get it. I get it, it's hard. All the easy stuff we've done, we're now into the hard stuff. We need to have a separate workstation because of this issue where there's 100 admins on any given workstation in the environment. Because the security tooling is not going to catch everything that an attacker is going to be doing. Because keep in mind that any agent that's installed that can run or install code makes a chain of attack from one management system into that system that you're using. So if you have an admin workstation that's being managed by the same SCCM system that manages all the other workstations, you have not solved the problem. So we want to make sure they're isolated. We want to disrupt the common attack playbook. So the system configuration is going to be separate administration, separate management, auto-patching. WSUS is a great way to do this. That way you don't have to implement a second SCCM for this. But we want to protect it. We want to firewall it. We want to lock it down. And this is the standard Microsoft tiering model slide, which you probably have already seen many times. And every time I talk to customers about this and I show them this slide, this is what I get. Like a very subtle no. So anyone that's been in had Hagee's classes or talks, you know that that means that I'm not doing this, I stop listening to you. So let's simplify it. Let's start with the part that really matters, our tier 0, our domain controllers, our domain admins. It's difficult to implement this. It's costly. People don't want to. It's okay to do part of it. It's okay to get some of this done because everything we do makes it harder for the attacker to do what they're doing. We want to implement tripwires. We want to make it hardened and more secure. We want to make sure that our tier 0 contains domain controllers, privileged accounts, ADFS, which is doing authentication. Too often we find ADFS servers, again, treated like regular servers. This is your authentication pathway and gateway into all of your cloud services. They need to be protected like DCs. Azure AD Connect servers, especially when you're synchronizing password hash data, they're like junior DCs for your environment. Password hashes are flowing through them every 2 minutes. PKI, etc. Convincing admins is tough because when you say, okay, admin, from now on you have to have a user workstation and an admin workstation, and that needs to be implemented by the end of the year. Guess what's going to happen? Okay, fine, got it, not a problem. So I've got this priority 1, this priority 1, this priority 1, this priority 1. And by the way, this is senior VPs and executives that told me these are my priorities, so guess what? I will put yours in the appropriate prioritized location. And I'll talk to you in a year or 2 about this. Because they're the ones that need to implement it, and they are not going to be happy about implementing it because it makes their life and job more difficult. So it's important to collaborate with them, work together as a team, talk about the problems, the challenges. Hey, I saw this guy at DerbyCon talking about this. It seems like a pretty big deal. I know we have MFA, I know we're using password vaults, but like, look at some of this stuff. It seems like it could be pretty bad. What can we do together to solve this? How can we come together with a good solution that's going to be workable in our environment? How do we talk to our managers and talk about a good way to move forward with this situation? Because ultimately, we need to convince our management too. We need to explain that if you don't want to be Sony, Target, Equifax, and I apologize for those who work for those companies now, but if you don't want to be in a situation like that, where you're in a breach scenario, where you're paying incident responders $500,000 an hour for months, it's very costly to go through that. You want to fix this problem now before it becomes a big issue. So you can make this workable. There's a couple different ways to do this. Ensuring it's a separate physical server or physical system is the best way to do it. But you could also have one system with a host OS and the guest VM that is your user VM. And you just use the host OS to RDP into an admin server. I'm not giving you the solution, I'm just giving you some ideas of how you can think about this. You don't want to be typing in your admin credentials on the keyboard that is on an untrusted system. You don't want to go through an untrusted system like a user environment to get to a trusted system because those credentials could be exposed. So something like this where you have the admin workstation with the user environment VM, the regular user account is what logs into the VM, and we call this a transition account. It's an account that's not privileged, but it's not the user account that logs onto this workstation just to then connect to an RDP system with their standard AD admin account. That way we protect the credentials. We harden this method of administration. If you have a password vault, it works very much the same way. Regular user account, user VM, transition account in the admin workstation to the password vault, which then potentially, hopefully, is MFA'd and would then proxy over to RDP. And the deployment of admin workstation should be at AD admins first. So I want you to focus on that first. I know this is hard. It will have one of the biggest impacts in your environment, along with doing the other good things like cleaning it up. But you don't want to forget about your virtual infrastructure. Most of the environments we walk into, people don't know who all the VMware admins are. There could be user accounts in those groups. We find user accounts in those groups, cloud admins, etc. So this is the new standard, making sure that these AD admins are well protected. But ultimately, we also need to reduce and limit our service count rights. Too often they're in domain admins. So I did a lot of research on this. I went through and looked at a lot of product vendor documentation, which, let me tell you, is just thrilling. Highly recommended. And a pattern emerged for what the service accounts or rights that are required for every account that was out there. And it became very clear to me, and hopefully I can do a little bit of Vegas magic so it becomes clear to you, but I found that every one of these required domain admins. Every one of them. even if they don't actually need it. And so what are some of the biggest problem child or children with this? Vulnerability scanning tools. Almost every organization of a certain size has a vulnerability scanning tool. They use one of the big three, right? They scan with a vulnerability scanning account for authenticated scans with admin rights because they have to be able to look at reg keys, etc. Well, when they run as a domain admin, they're scanning workstations, servers, domain controllers. If you have unconstrained delegation in your environment on a server, on an account, when this vulnerability scanning tool hits it, guess what? The Kerberos TGT is dropped into memory on that system. This is dangerous. We want to separate these out. At a minimum, make sure your vulnerability scanning tool is only scanning user accounts. User workstations, workstations themselves. And then something else that's doing servers, something else that's doing domain controllers. There are vendors here. Talk to the vendors. Ask them how that you can do this. How can I tier these out with separate service accounts? If they say we can't do that, tell them that that's a requirement. It needs to start here with the people that spend money. I can't change this. You can. For those people that are talking to vendors and getting them in and working on these contracts. You can change this now. Ask them what their roadmap is for this. It should be on the roadmap. A vulnerability scanning tool should not be the major vulnerability in an Active Directory environment because of the service account requirements, right? It's a little ironic, don't you think? Backup. Often backup service accounts are in domain admins. We can move those to backup operators a lot of times, but sometimes there are backups, Active Directory backup tools that need to be able to restore attributes. And so in order to do that, sometimes they need additional permissions. Figure out what that is and ensure that your backup solution is what requires that. Or ask the backup vendor, what are the different options that I have? How can I go to a least privilege type model with this because I need to? VPN. Oh, VPN. Way too often do I find VPN service accounts in domain admins. Why? Because we need to change the password for users when their password expires, and they can't actually VPN and change their password, so it's a catch-22, so domain admin. Problem solved. Like, I'm good, right? No, we can delegate those rights. It's very easy to delegate the rights to change passwords for users for a VPN service account. And SQL. Oh, wow. Yeah, still today, SQL service accounts are in DA. Or just as bad, the default administrator account in the Active Directory domain has a service principal name associated with it for a SQL service that isn't around anymore. What does that mean? I can Kerberos the actual default domain administrator account and probably crack it because its password hasn't changed in 5 years. This is common. We see these things all the time. So I have a little bonus section here, so I'm going to skip this and go to this. So a new sneaky 80 persistence, which I haven't talked about in a while. So this is something that, let's just say I ran into, figured out over the summer. Let's say we get DA rights. We implant a custom password filter on a DC or modify an existing one. And we set a target attribute as something like serial number. Now, I want to point out that this isn't new, okay? There's an open source password filter example link at the bottom where you can go to GitHub. It's super alpha. I don't recommend you actually put this on DCs. But it gives you an example of what the code is, of how a password filter works. A password filter, put simply, is when a user attempts to change their password, the domain controller's LSAS checks the password filter to see if it meets certain rules. What does this mean? This means the password filter gets the user's password when they are changing it. So what we're doing here is, whenever the password filter is checked, we know the users have changed the password. We're going to take that password that they're setting that's new, we're going to hash it and put it onto this attribute. Or we can encode it. Or we can do some method that we can reverse and we know what it is. But it looks pretty, like, there's a serial number here and it's like some number. Okay, probably, I don't know what that is, but it's probably fine, right? So as the attacker, with persistence, all we have to do is look for the default admin account in the environment and then enumerate the value of the serial number and then just crack it. And then we know what it is, or reverse it, depending on what we're using. And all we have to do is enumerate all the users with data and that target attribute. And every time the user's passwords change, we're going to get those password changes. So I started thinking evil about this, and I was like, what is the best way that I could do this? What would have the most impact? I mean, obviously that's bad, sure. But what if I could go after something else that really doesn't change very often? That could be kind of wicked. I get the KERBGT password hash, or actually the actual password, and then it's not going to change for a while. So again, I didn't come up with this. I ran into this, figured something out, and then I saw that MITRE ATT&CK actually had a full piece of information on the bottom that you can read about it. And apparently there's ransomware and some other things that are actually leveraging this. So you definitely want to check to see what password filters are installed, or that what you have installed is the same thing that you installed. So to wrap up, traditional AD administration has to evolve. You've got to do better than what we had before. It's hard, but there's priorities to this. Remove accounts and service accounts from AD privilege groups that don't need to be there. Protect and isolate our AD admin credentials, because those matter tremendously. Work on these hard things. Work on removing these permissions and checking to make sure these permissions get cleaned up. I'm going to have presentations, this slide deck on presentations.adsecurity.org at some point after this talk, this weekend. That's been my time. Thank you so much for yours. I appreciate it.